Hello, welcome to video 3. Today we're looking at conditional probability. Uh, and this is written kind of funny. It has P of A given B. This means that the probability of A given that we know B has already occurred. So we have to get used to this notation as we're doing it. Now, here we have those same shapes. From the shapes below, what is the probability that a shape is purple given the fact that it's a rectangle? So probability of purple given the fact that it's a rectangle. So this is how we would write that. Probability is purple given that it's a rectangle. So what this does is this lowers our sample space. So no longer are we looking at all of the shapes. Now we are just looking at whatever's on the right, which is our rectangle. So we look at these rectangles, which I'm outlining in yellow. And out of those, how many of them are purple? 3. So we have 3 out of our total sample space, which is now 6. So 3/6, or 1/2 of the rectangles are purple. Now what's the probability at circle, given that it's blue? So now we just look at our blue sample space. There are 3 objects, and only one of them is a circle. What is the probability it's green, given the fact that it's a circle? So now we just look at our circles. The probability that it's green is 2 out of 4, which is 1/2. Now it says find the probability that you roll a die and you roll a prime number given that it's less than 4. So first we look at our sample space. So given that it's less than 4, it's going to reduce our sample space to just these values. So out of those values, what's going to be the probability that is prime? So prime numbers are going to be 2 and 3. So it's going to be 2 out of our sample space of 4. So that is also 1/2 probability. Next one, 2 dice are rolled. What's the probability that the sum is greater than 9, given that the first die is greater than 4? Alright, so now we know that the first die is greater than 4. So when I write this, we're going to say the probability that the sum is greater than 9, given that the first die, so I'll say first, is greater than 4. So we look, and the first die is the top one. So greater than 4, our sample space is reduced to just these values. So out of those values, we will need to find the probability that the sum is greater than 9. So the sum is greater than 9 would be 1, 2, 3, 4, 5. So 5 out of 12. Oop, is going to be my probability. Let's try another one. Now if we flip a coin and roll a dice, what is the sample space? So our sample space, we could either get heads and a 1, we could get heads and a 2, heads and a 3, heads and a 4, heads and a 5, heads and a 6, or we could get tails and a 1, tails and a 2, tails and a 3, and so on. So that's our sample space. So what's the probability we get a die that's greater than 4, given the fact that our coin is heads? So if we look back, and we reduce our sample space to just the coin is heads, now we want to find out what's the probability that the die is greater than 4. Die is greater than 4, that's going to be 5 and 6, so that's 2 out of 6. So our answer is 2 out of 6, which is 1/3. Now, what's the probability that our die is greater than 4? So if we took the whole thing, if our die is greater than 4, out of the whole thing, that's 12 items, and that we would have 4. So this one would be 4/12, which when we divide it out is 1/3. Now sometimes when these two things come out to be the same, we say that these two events are independent. And what that means is it doesn't matter if coins are heads or not, because these two do not depend on each other. So finding this, if you reduce your sample size, it doesn't change the actual probability. We'll talk more about that in future videos. All right, assume two dice are rolled. What's the probability that the first die is 4 and the second die is greater than 2? I just realized this problem's in the wrong section, so we actually are done with this one for conditional probabilities. This one is in the and, so let's not worry about it. All right, so this is the end of the third video. Now you can do your on your own.